Hi, so this deck of cards was compiled to facilitate getting through standalone questions dealing with dot structures. And it's the first um, volume in this dot structure series, okay? All right, so draw the Lewis dot structure for carbon monoxide. What's the Lewis dot structure for carbon monoxide? All right, so here goes the Lewis dot structure for carbon monoxide. There's a triple bond between carbon and oxygen, but this is just one of the resonance structures because a pair of electrons can go on to the oxygen to get a double bond. But in this resonance structure, there's a partial negative charge on the carbon and a formal charge of +1 on the oxygen. And this is something you need to memorize, okay? All right. Draw the two Lewis dot structures for thiocyanate. So remember thio, whatever is the suffix for sulfur. And cyanate, you should know what that looks like. There's a carbon and a nitrogen. So what are the two Lewis dot structures? All right, so here goes your two Lewis dot structures. In the first structure, there's a partial negative charge on sulfur. And sulfur, although sulfur has 6 valence electrons, it can carry a partial negative charge because it's able to expand its octet. So, yeah. And then in the second Lewis dot structure, there's a partial negative charge on the nitrogen because we took this pair of electrons. Well, we started over here with sulfur, made a double bond between the carbon and then passed on the pair of electrons to nitrogen. So we pass the charge on to nitrogen. And resonance just stabilizes a molecule overall. So memorize these two structures, or memorize one and then deduce the other. Write the molecular formula for nitrate. So what's the molecular formula for nitrate? So this is the molecular, well, I think this is the structural formula actually. The molecular formula would be NO3. It would be NO3, and then there's a charge of 3 negative because each oxygen carries a formal charge of -1. And notice you can probably also do some type of resonance structure and make a double bond. All right, so this is something that you also need to be able to memorize. So you can memorize this structure and deduce the others, but this was the original question. What's the molecular formula? Bond order. So bond order, this is probably a term that a lot of people aren't that familiar with, but it's just good to have in the back of your mind for conceptual understanding. So bond order is the total number of blank divided by the number of attaching atoms. And when I say attaching atoms, I mean, let's say you have a methane, it would have 4 attaching atoms because it would have 4 hydrogens attached to the carbon. So it's the number of bonds divided by the number of attaching atoms. Okay. Draw the structural formula. So what's the structure of sulfur dioxide showing the correct molecular geometry? So what is it? Okay, so here we have it. this is the structural formula for sulfur dioxide. Notice it's bent because there's an electron cloud right here. So this is something you need to memorize. Just take it all in for a moment. There's double bonds between the oxygen. And this structure makes sense because oxygen has 6, valence electrons. So this is kind of showing this. And so does sulfur. So this structure makes a whole lot of sense. And the molecular geometry is bent. But the electronic geometry would be trigonal planar. And if you don't know what I mean by that, Google it. Draw the structural formula for water, showing the correct molecular geometry. I actually don't know the technical chemical name for water. Would it be dihydrogen oxide, I guess? I'm not sure. So here goes the structural formula. It's bent due to the 2 lone pairs of electrons on hydrogen. So this is why the structure is bent as opposed to linear, because those electron clouds are walling out and just pressing down the hydrogen clouds. Draw the Lewis dot structure for the chlorite ion, showing the correct molecular geometry. Alright, so chloride is also bent, has 2 lone pairs of electrons, but in this case it also has like a negative formal charge, giving the overall ion a charge of -1. Okay, so this whole thing has a charge of -1. And this structure makes sense, so just take it all in. Draw the Lewis dot structure for triiodide. Draw the Lewis dot structure for triiodide. It's I3 and the whole thing has a charge of -1, showing the correct molecular geometry. Alright? Alright, so here goes triiodide. Each iodine has 7 valence electrons. The structure makes sense. Notice the middle iodine has 3 pairs of unpaired electrons. This is why the structure is linear as opposed to being bent, because the way it works out is that, if you were to ignore this pair, it would be bent, but because you have this pair, it's kind of pushing back down on, the effect that these would create, which would be bent. So the sum total is a linear geometry. Iodine can or can expand its octet. So what's up with iodine? Can it or can it not expand its octet? And I want to say certain elements can expand their octet because they have a d orbital, but that's not necessarily true because sulfur also can expand and it doesn't have a d orbital, so I'm not exactly sure why. But luckily you don't need to know that level of detail for the MCAT, but if you need to know or want to know, just Google it. And don't spend too much time like researching, because if you were to research every single thing that you need, you would run out of time. So it can expand its octet. Alright? Draw the Lewis dot structure for periodic acid, showing the correct molecular geometry. Per means something extra. Alright, so here we have our periodic acid. Remember, iodine is a halide, so it has, like 7 valence electrons. So here goes 1, 2, 3, 4, 5, 6, 7. So basically what I'm trying to say is the structure makes sense. It has 6 oxygens, and 5 of those oxygens have attached hydrogens, and 1 just has a double bond to iodine, okay? So take it all in. It's a lot to take in, but you need to memorize it. So the more exposure you have to this, just repeat the video a bunch of times. You'll get familiar with it, trust me. In the beginning, I was like, what the? Draw the Lewis dot structure for metaperiodic acid, showing the correct molecular geometry. So what's the structure for metaperiodic acid? Here it goes. It has the trigonal pyramidal molecular geometry, and it's triple bonded to 3 of the 4 oxygens that it's attached to. All right, so this would be H, I, O, 4. All right, and that proton takes care of the -1 charge of the like metaiodide. I don't know how you pronounce that. The conjugate base. And 1 oxygen in metaiodic acid has the protic or acidic hydrogen attached to it. Draw the Lewis dot structure for chlorine trifluoride, showing the correct molecular geometry. All right, it has a T shape, and both of these molecules, chlorine and fluorine, are halides, so they're both represented. I said they're both represented. They're both represented having 7 valence electrons each.